Welcome back. Lots more still to come on Daily Planet today, like how to track a killer tornado with up-to-the-minute technology.
That's coming right toward us.
Plus,
today I'm here at a secret location to meet with the Halton Regional Police, and we are about to dissect a disaster. But right now we're turning our attention to hurricanes. 8 years ago this week, Hurricane Katrina wreaked havoc on the U.S. South Coast, especially Louisiana.
things were a lot worse in that particular state because the levees there failed. And since then, there's been a big focus on rebuilding, but also redesigning.
This next story takes us to Colorado, a landlocked state and a rather unlikely place to find that science is making levees more effective than ever.
This is what can happen. Mother Nature washing out the very things designed to keep her at bay.
As soon as Katrina happened, a group of us realized that we had to do something.
Chris Thornton isn't afraid to get wet. As a hydraulics engineer, it's just part of his job at Colorado State University.
What's the sequence of what you have coming, Brian?
30, 39, 54, 18.
What we'll have over the course of the next 5 minutes is 4 rather large waves. So we're going to have a really large wave come here in just a little bit. You're not going to want to stand here because there's a chance that this will overtop a little bit.
Hurricanes are a permanent reality in the U.S. Since 1950, U.S. coastlines have been pummeled by 2 Category 5 and 7 Category 4 storms. This water gusher is designed to help those vulnerable regions prepare.
Well, what we've done is brought the ocean to Colorado. We're looking at simulating wave overtopping for levees. Post-Katrina, what we've learned is that we didn't really understand the armoring of the levee systems. So this simulator was built in an effort to be able to evaluate the storm conditions that are expected for 100, 200, 500-year storm events and be able to then evaluate solutions that would allow us to best armor those levees and ensure the safety of the public.
That safety rides on the shoulders of the U.S. Army Corps of Engineers. They have a vested interest in these tests because they're the ones that design and build levees.
Are these new?
They are. What they're called is surfboards. And the idea is that these 3 locations along the slope, we're able to measure the depth of flow of each wave that comes through.
Melissa is a U.S. Army Corps engineer from Jacksonville. Coming here means she can witness the effects of a simulated disaster.
I wanted this data so bad.
There's not data like this anywhere.
I know.
She's about to see how Louisiana clay stands up to what Chris's team throws at it.
Yes, this will be the largest wave.
We had to have it excavated from the Barrow pits in New Orleans and shipped to Colorado. So we have this exact soil type that they will actually construct their levees from. It's a very stiff clay, so it has very high cohesion, much greater than a loam or a sand. And it's simulating a typical levee section that we use here in the United States of a 3-to-1 slope transitioning into a 25-to-1 slope. So we release that volume of water at a given rate for a given period of time so that we can simulate the waves crashing over the top crest of a levee and then accelerating down the backside. We're looking at what happens on this protected side of the levees, where that erosion occurs, how quickly it moves through the levee, breaches the levee, and then the system fails. 5 for the big one, guys. One of the telltales of erosion also is how dirty it is the water as it's coming off the surface. If it's clean like this, we know we really haven't breached that top layer and started to have gully formation yet. I am surprised at how well it's holding together. It's showing us, and people that count on this type of soil, that they're lucky. We pounded that tray with waves today. We gave it pretty much everything we could throw at it. It's really not the duration of a Category 5 hurricane, but certainly the volumes of water far exceeded what my expectation was. Sand would have been gone a long time ago.
That's what concerns Melissa and her colleague Elizabeth. They know all about sand.
In Florida, we have sand, and an abundant amount of sand. Sand is very easily erodible. I design earthen embankments. The importance of the soil in that respect is that it needs to be there. It can't wash away. If it washes away, we have a problem.
Our quest was to find an acceptable overtopping rate that our Florida impoundments can withstand.
The results, much different than the clay. These grasses were pushed to the limit, providing critical info for designing blockades to withstand the next big hurricane.
So we are breaking ground with new criteria, new acceptable overwash rates for sandy impoundments.
Further west in Louisiana, levees have been heightened and armored using the best information to protect against a breach like this.
The results that have come out of the testing that we've done for the Corps down in New Orleans has put them head and shoulders above where they were previously, of being able to assess and armor the levee systems that they have. Without this information, they would still be guessing. It's very exciting. I love my job. I mean, this is why I get up every day, is to be able to solve these kind of problems and figure out what we can do next.